Transaction log shipping tips and tricks. This is one of those technologies that looks really simple at first glance and then has all kinds of really cool ways that you can configure it that are not immediately obvious when you look at books online. So we're going to shortly explain what it is and then look at several increasingly hard ways of using log shipping to do amazing stuff. So we'll start out with just a quick overview of what log shipping is. You have a primary SQL server, we'll call it Node 1 up here. Node 1 is where everyone's connecting to for their inserts, updates, deletes, selects, whatever. Every 5 minutes, 10 minutes, whatever it is, I'm going to go write my log backups over to some other folder. In a perfect world, this is a file share that's not on the same storage as my SQL server. Because I can tell you so many horrible stories about me doing my backups to a SAN, and then when the SAN vaporized, so did my backups, because my SQL Server data and my backups were on the same SAN. In a perfect world, especially in larger companies, you write your backups to a separate place. Commvault and Data Domain, those appliances, don't work as well for this because they don't let people read quickly off of those log backup shares. They're great for just vaporizing the server and rebuilding it from scratch, but usually when I want to do log shipping, I have to write to a folder somewhere and then have Commvault or Data Domain also sweep the files off that folder. So I'm going to write my backups out here every, say, 5 minutes or 10 minutes. Then over on server 2, I'm just going to be restoring these log files continuously. So the box is like 5 minutes, 10 minutes behind, depending on how you set it up. You can even make an argument for running them every minute. I have a lot of shops actually who run their log backups every single minute, which might sound like it's a huge amount of overhead, and it's actually the opposite. You're nibbling off progress all hour long as you're sitting there writing new transactions. You're just nibbling off small transaction log backups, as opposed to waiting for several minutes and then trying to grab all the data at once. People notice that when you only do log backups, say, once an hour, the whole server slows down and the lights go dim. It gets even worse if you've got several SQL servers or dozens of SQL servers on exactly the same backup schedule. So every hour, whammo, your backup share suddenly falls over. Setting up log shipping is really simple. The way that you do it is you just start restoring your backups on another server, and there's no reason that you can't restore your backups on lots of servers. Well, there is one reason, that reason being licensing. For every one primary you buy, you still only get one secondary for free, assuming that you've got software assurance. As you start to restore your backups to more places, that means more licensing costs. As we've talked about, there's all these different terminologies between the different methods, between replication, mirroring, log shipping. You'll usually hear me say primary and secondary, especially when I'm dealing with log shipping. Other people will even call log shipping subscribers, but the same basic idea here is that I've got a read-only, readable server. You can't tell if a database is log shipped just by looking at it in Object Explorer, because remember, the whole technology here is that someone's just restoring my backups. And I don't know if someone's restoring my backups. All I know is that I'm taking backups. If you do use the native tools, and SQL servers had pretty good log shipping since about 2012, if you use the native built-in tools, you can see it if you right-click on the database in SSMS and go into Properties. Down there's a transaction log shipping tab in database properties where you can set up your principals and as many subscribers as you want or secondaries as you want. If you're using third-party tools, if you're using Idera SQL Save, Quest Lightspeed, Redgate SQL Backup, all those make it a little harder because they tend to, I say they make it harder, they make log shipping way easier. It's just that they're doing it in their tool instead of what's obvious in SQL Server Management Studio. Anytime you see LS jobs, LS Alert or LS Backup, you'll see multiples of these from multiple database subscribers or for databases that are being log shipped. Over on the secondary, you'll usually see the databases in Object Explorer is restoring. This means that they're, of course, in the process of restoring transaction log backups. Even when the restore command finishes, the database still shows this, unless you set this database up as readable. This is an option with log shipping where you can put the databases in standby mode in between each restore, so people can query the databases when you're not doing restores. Unfortunately, the restores can't proceed until people quit querying. So at first it sounds like this isn't useful for reporting, but here's how it works. You set up your scheduled jobs to do the restore to only happen, say, 5 p.m. to 9 a.m., or whatever working hours work for your company, so that at the end of the business day, all of a sudden the log shipping jobs fire off, they restore the database to catch it up to speed, and then in the morning, people have a read-only copy all day long. If you have an emergency where you got to get people out of the database and go live with this thing, you simply kick them all off and manually run that restoring job to catch your database up to speed. And then whammo, you can make this guy the primary and suddenly start satisfying transaction workloads out of there. This works really well. There's no performance overhead on the primary because you are taking backups anyway. If the database was important enough to fail over, you were already putting it in full recovery model with transaction log backups. There's no additional overhead on the primary, no matter how many secondaries you have. You could have a dozen of them if you wanted to. They don't have to be on the same version of SQL Server. They don't have to be on the same edition of SQL Server. You can log ship up to newer versions, and you can log ship down to lower editions, meaning I can go from an Enterprise Edition SQL Server down to a Standard Edition SQL Server, as long as I'm not using any Enterprise-only features inside the database. Before SQL Server 2016 Service Pack 1, that meant things like compression, partitioning, transparent data encryption. Starting with 2016 Service Pack 1, you can even do compression and partitioning in Standard Edition. So you can take that big monster data warehouse that you have, or super critical OLTP box, restore it down to onto a Standard Edition box, and run your reporting against it. Ta-da! It's really useful for scale-out reads. It's not perfect. It's not quite as cool as availability groups. For example, I can't fail over very quickly between a primary and a secondary and keep the same name. I have to sync jobs around back and forth. I have to sync logins back and forth. But as you read through this, as you read through what the restrictions are, they're going to ring a whole lot of bells. It's basically the same as availability groups. It's like the 1998 version of always-on availability groups. It's way easier. It's almost bulletproof. Doesn't matter what you do inside the database. There's no gotchas around clustering or being in the same domain. We've even got a white paper in our first responder kit about how you can log ship up to Google Cloud. You can take your databases, copy their backups, sync them up with PowerShell up to a secondary location up in Google Cloud storage, and then automatically spin up a SQL server and start restoring those backups. Run CheckDB, send yourself an email, all kinds of cool stuff like that. Then you're just paying by the hour for licensing up in Google Cloud. Same thing with paying by the hour for hardware. Your DR data center doesn't have to cost you anything until it's time to go fail over. I say doesn't have to cost you anything. You're going to pay for the space for the backups, but that's dirt cheap compared to running a live SQL server up there. So there's 4 ways that we see log shipping getting used. And I'm going to start with the obvious, easy one, and that's disaster recovery, the thing that most people use log shipping for. When we think about failovers, planned failovers are when you want to do patching or you want to have some kind of high availability so that if a box goes bump in the night, I'm going to gracefully, quickly plan failover over to another node. Unplanned failover, this is what's way more common for log shipping. People say, I lose the whole data center. Oh my God, I got all this work to do. Let's just stand up another SQL or, fail over to another data center here really quickly. And this is how people frequently get incentivized into using log shipping. Say that for my server offline scenario, in the event of a high availability bump in the night, I'm willing to lose 5 minutes of data and be down for 30 minutes. In the event of database corruption, I'm willing to be down or lose 5 minutes of data and be down for 4 hours. In the event of oops deletes, I'm willing to lose 5 minutes of data and be down for 4 hours. In the event of data center being offline, I'm willing to lose 30 minutes of data and be down for 4 hours. Now, my sketch out architecture for this, I'm not saying that log shipping is going to work for this. You might be able to push it, but this one might be kind of tight. It might be tough to get a human being to get to a keyboard, sober up, and issue the right commands in order to migrate over to on log shipping. But remember, I need both this and this. I need something in my primary data center that's going to protect me in the event that I go bump in the night. And I also need something in another data center. So we're back to our classic 2 and 1 scenario. 2 in my primary data center and 1 in a secondary offsite DR data center. Remember, for every 1 primary that I buy, I only get 1 free standby. The other one, I'm going to have to pay for licensing. Now, in this case, the customer has said, we've got just a 50 gig database, so it's not a big monster. But performance, we don't really care about in the DR data center. We care a lot about it in the primary data center. We need our inserts, updates, and deletes to go fast. We're really serious about high performance over here. But things could be slower and a little bit degraded over here. Now, as you start to look at your charts, when you look at how much data you're willing to lose and how long you're allowed to be down for, there's a little data loss allowed here. It doesn't have to be right away. So what I might be willing to do in my primary data center is use Enterprise Edition and do async database mirroring in my primary. Now, for every 1 primary that I buy, I get 1 secondary, but that's it. So in this case, my primary and my secondary most will probably both be enterprise in order to get me that async database mirroring. Also lets me use large amounts of memory, use big old monster servers, you name it. Take a quick note here. However, down in DR, I'm totally okay with using a crappy server. I'm okay with using, say, a 4-core, 16 gigs of RAM, because I have to pay for licensing for this separately. Every 1 primary, I get 1 secondary. There's my 2 enterprise in New York. Now for my 3rd one over in DR, let's keep our costs as cheap as possible. So let's say we have our failure. In New York City, the electricity goes out at 2:30 p.m. My DBA takes a while to get to a keyboard and get sober. Look, it was the weekend. There was a sale on Bloody Marys or mimosas or whatever, so he got hammered early in the morning. Then when he goes and looks at his log shipped secondary, he looks at the canary table and says, well, it's current as of 2:28 p.m. The New York data center, we've decided it's going to be offline for an extended period of time, so screw it. We're going to go ahead and bring this database online over in Chicago. To do this, all I have to do is run this 1-line command, restore database with recovery. Normally, when you think about running a restore database command, you think that there's going to be a file involved, that you're going to point to a specific file name. Whenever you just want to bring a log ship secondary online and make it writable, this is the command that you run simply with recovery. From that point forward, all my sysadmins get started about pointing the connection strings in the app over to my log shipped guy in the disaster recovery data center, but it is literally a 1-line command. One of the things I love about database mirroring is that I can empower my sysadmins to do this. I can give them 1 query to just list out the contents of the canary tables so they can do a sanity check and know how far behind we are. And then a secondary query to simply bring these databases online, and we're done. This way, I don't even have to put down the mimosas or the Bloody Marys. I'm still getting drunk on the weekend. That's totally not true because I have to come in and fix everything else. then whenever my New York City data center comes back up, my New York City SQL servers are still running. They are still able to take inserts, updates, and deletes. I may want to just go take a backup there so I can figure out exactly how much data that I lost. But if I want to fail back now from Chicago over to New York, I got to start pushing data back going the other way. Log shipping doesn't directly have this automated and built in. I'll show you how you can do it in a minute. But it's not as quick and easy as a right-click failover back and forth like we get with database mirroring. One thing to know, when you fail over to DR, you've got to take a backup, because odds are you don't have a full backup down there in DR. Odds are you were only doing your full backups up in the primary data center in New York City. And then whenever we failed over down there, I may not have access to those full backups. Excuse me. I also want to make sure over in my DR data center that my log shipping or my transaction log backups just start working right away. Ola Hollengren scripts make this super easy. You'll see me continuously pushing those. Everyone I know who ever had their own backup scripts stopped writing them as soon as they saw Ola Hollengren scripts. Minionware's Minion backup is also good as well. I don't have as much personal experience with it, but I hear great things about it from enterprise shops, people with hundreds of database servers, that it's much easier to use because it's table driven. With log shipping, in a perfect world, I'm going to practice this unplanned failover piece first so that I can script it out for my sysadmins, because there's no reason that a DBA has to get involved in order to do log shipping failovers. It's not that I want to get out of my work. It's just that I want people to be able to jump in and fix something quickly before I even get there. And then I'll start cleaning up some of the other SQL servers that I have to go deal with that are not quite as easy to manage. That's the most common scenario for log shipping. Everybody thinks about DR failovers. You can actually use DR for higher availability. Notice I didn't say high availability, because what you and I probably think about as high availability may not exactly match what I'm about to describe here. Let's say that I got a customer and he's got a 600 gig database. That's not impossible. That is a possible thing that you could set up with log shipping and be fairly performant. But these guys are also cheap. They want to use standard edition. Only standard edition. They don't want to go to enterprise edition if they can avoid it. This is really just a big monster reporting server, and they're okay with queries being a little bit on the slow side. I say big monster, 600 gigs isn't that big these days, but you get a rough idea where we're going here. For server offline, in the event that I lose my primary, we're willing to lose 10 minutes of data, and we're willing to be down for 2 hours. Oh man, that's luxurious. That's fantastic. I can have a nap and maybe some, chocolates before I go into work at that rate. In the event of data corruption, we're okay being losing 10 minutes of data and being down for 2 hours. Oops deletes, we're okay losing 10 minutes and being down for 2 hours. And these guys don't even care about a DR failover. They're not even worried what happens when they lose a data center. They just don't want to lose more than 12 hours worth of data. So I need to copy the data out somewhere, but I may not have another server ready to go. What this tells you when you look at licensing and math is I really only need 2 servers. In order to handle the server offline scenario, I need 2 servers that are sitting next to each other in the same data center, but I don't need to pay for anything out in a secondary data center. Log shipping is suddenly very interesting here, because I can do log shipping without anything fancy like failover clustering. I don't have to worry about synchronous writes in standard edition's mirroring. See, these guys only wanted to use standard edition, and mirroring in standard edition is synchronous. Every write that I do to one server has to also be written to the other server. That's going to slow me down, and people are already going to be frustrated with standard edition and performance if I'm dealing with a 600 gig database. It's not impossible. It's doable. It's just harder work. Every now and then, these guys also decide they're going to do big batch updates. It's a reporting server, so they do big bulk loads of data and big trashing of data. Because of that, synchronous mirroring would really blow. So here's how we're going to set it up. These guys are based out of Atlanta, so we're going to put two SQL servers right next to each other in Atlanta. And the primary is just going to do its backups every minute, its log file backups every minute off to a file share. And then because I'm doing directly to a file share that's in the same data center, I don't even have to worry about copying the files from one place to another. If you're doing log shipping to DR, you want to copy these backups down to DR so that you've got them in case the primary data center blows chunks. Now over on the secondary, he's just going to point at that same file share and restore the backups every minute straight from there. Now this gets me higher availability. I can move back and forth between each of these SQL servers, but these guys have an even more ambitious goal. They've been burned, as we'll talk about on Friday with the patching, they've been burned by some bad patches with SQL Server. And they want to do their patching because, after all, cumulative updates come out every 2 months, and a lot of these fix incorrect query results bugs. These guys actually want to stay current on patching. And they want to make sure that everybody's current with log shipping, that they're used to failing over back and forth. Here's how they're going to do it. First off, they're going to sign off on a list of approved changes. This is the cumulative update and the Windows Service Pack or Windows hotfixes that we're going to go apply. We're going to go test them in our pre-prod environment, aka staging. Everybody's going to agree that it works. Then, when it's time to go patch production, here's how we're going to do it. Let's say that SQL 1 is the primary and SQL 2 is the secondary. It doesn't always have to be. These two boxes are identical, but we're just going to start there. So if SQL 1 is the primary, I'm going to go apply the updates to SQL 2 during the week. And I say this to be important because I want my DBAs doing as much work as they can during the week, fully caffeinated, ready to go, awake at their keyboards, listening to their favorite music, not exhausted and beat down and burned out on a Saturday night, trying to get out of there as quickly as possible. So what I'm going to have them do is I'm going to have them do this during the week, say on a Thursday, and then make sure that SQL 2 behaves properly for 2 days. You'll see why that's important when we start talking about patching. On Saturday night, whenever my maintenance window is, I'm going to do a planned failover. I'm going to go from SQL 1 over to SQL 2, and I'm going to reverse log ship. I'm going to go from SQL 2 back to SQL 1. I'm going to wait another 2 days. And then on like Tuesday or Wednesday in the middle of the week, bright and sober, lots of coffee, good music on the headphones, then I'm going to go back and patch SQL 1. And then after that gets done, I'm not going to fail back. We're done. We did our little patching, and the whole thing was like a 60-second outage window. This is what the outage window looks like. Every minute, I'm taking log backups over on SQL 1. I'm going to disable that job, and then I'm going to take my own log backup manually with no recovery. That's right, no recovery is actually a backup command too. I mentioned earlier that restore with no recovery brings the database live. Well, backup with no recovery kills the database. That's not a really good way of saying it. But what it does is it seals the database as read-only. It gets every last transaction inside the database, switches it to read-only, actually restoring, and then that little log file that's called the tail of the log backup is magical gold that then I can go restore over onto SQL 2. It brings the database back to life over on SQL 2. And here's the amazing part. My log backups over on SQL 2 can immediately be restored over on SQL 1. That's right. I don't have to reinitialize log shipping going back the other way with a full backup. All I have to do is restore with that tail of the log backup or with the subsequent log backups over on the other SQL server. you can actually plan to fail over back and forth. Now, this only works with planned failovers because you have to take that backup with no recovery. But by doing that, you can lob whoever's active back and forth. It's not as seamless as it sounds. It is a little bit of hard work. But by doing this, it enables me to use log shipping as a higher availability strategy. I don't call this high availability. It is just higher availability. And it only worked with planned failovers back and forth. Anything that's unplanned, I won't be able to get that tail of the log backup. But speaking of planned failovers, let's think back to scenario number 1 when I had a pair of Enterprise Edition servers in New York City and a DR server somewhere else. Well, when I lost New York and I switched over to the primary being over here, I can, if I want, start setting up log shipping going back the other way, then take the tail of the log backup in Chicago, restore it over onto my mirrors, and they're brought back to life, and they can simply start log shipping going back in the other direction without restoring the full, without rebuilding and pushing a full backup all the way across the wire. This is really helpful as your database sizes grow. It's so much easier to pull this off with, say, a 1 terabyte, 2 terabyte, 10 terabyte database. That's very hard when you say, just take a full backup and restore it somewhere else. Copying it across the wire can be absolute nightmare. Whenever I do a backup with no recovery or a restore of that tail of the log file, that's the kind of thing that I want to script out ahead of time, but I don't want it happening via scripts. Because when you run a backup with no recovery, you are taking the database offline. That's the kind of thing that I would want a human being to do, because if anything breaks on that script, I want someone who's experienced troubleshooting that thing. I did say earlier that for DR, I'm okay with my sysadmins running restore with recovery. That's not how I feel about backup with no recovery. In order to make this whole process of failing over back and forth a little easier, one of the coolest tricks is a DNS CNAME. A DNS CNAME is like the old school version of an availability group's listener. An AG listener will automatically point to whoever's the primary at any given time. Well, a DNS CNAME is like an alias that you can move around to different SQL servers. This way, your applications don't have to change their connection string. They just have one name, and then you, as the database administrator, can change who that points to. There are gotchas with this, usually around enterprises and security. Often the database administrators will have different capabilities of whether or not they can change it. You may not have permissions to change this. You may have to file a ticket with your sysadmin team for them to change the CNAME for you. Fred asks, how is a CNAME different than a virtual IP? With a CNAME, it can be in any subnet. You can move it around from one subnet to another, whereas a virtual IP is traditionally located just in one subnet, and when you need to fail over from, say, New York to Atlanta, the IP address no longer works. So the last scenario that log shipping is good for, we call this crazy mode for log shipping, or like super power up mode. Let's say that you have a really large database. Let's say it's 10 terabytes, 15 terabytes. And you need to scale out reads, and availability groups doesn't cut it. Say that you need 10 or 20 readable SQL servers. The easiest way for me to explain this is with a diagram. Let's say over on the left-hand side, I have my primary SQL server. This one is writable. And I have all kinds of application servers that need to push data into this. This guy is taking his backups every 5 minutes, 10 minutes, whatever. Then I have a whole bunch of other SQL servers that are all readable. They're doing log shipping, but I'm going to have a special setup that I'm going to talk about here in a second. All of these guys are readable, and I have a bunch of reporting users that are all hitting app servers, web servers, reporting servers, and they go through a load balancer, F5, NetScaler, whoever you use for big load balancers, and the load balancers direct queries around to whichever SQL servers are readable and are relatively caught up to date. Now, when it's time for me to update one group of my SQL servers, what I do is I run a script that tells the load balancer, I want you to take these SQL servers out of the load balancing pool. Whatever queries are running right now on those SQL servers, they can continue to finish, but don't start any new queries on these instances. Then I'm going to watch and wait. Whenever the last queries finish, I'm going to kick off a set of restores. I'm not going to restore the full backup. All I have to do is restore the log backups since the last time these guys had their logs restored. Maybe I do this every 15 minutes, every 30 minutes, every hour. I wait for the restores to finish, and then whenever these guys' restores are finished, I run another script that talks to this load balancer and says, put these SQL servers back into the available querying pool, but now take this group of SQL servers out of the querying pool. We're going to repeat the exact same process down here. We're going to wait for our queries to finish. Then we're going to run our restores down here, catch these guys back up to speed. Then I can flip right back over and do this group of SQL servers. The goal here is to get a lot of SQL servers that are always kind of close to real time, say within an hour, on a big monster database where people can run truly heinous queries. This is not easy. This is a lot of work. Everything that I've just described here, this is not something that's built into the GUI. It's not something that's built into SQL Server. It's going to be different for your applications, for your load balancer, F5, NetScaler, or whatever. It can be different based on your size of database and whether you want to use logs or differentials. And this is when it breaks, there's somebody's pretty smart has got to get involved, because the load balancer can email you when it does break. Hey, we're down to a certain number of SQL servers and no one's gotten a restore within the last hour. But then you actually have to have real human beings get in there and troubleshoot your PowerShell scripts, your database restore scripts, maybe take manual action in order to catch some of the secondaries up to speed. We call this crazy mode because it really is hard. Javier asks, wouldn't replication be easier? See, it depends on whether or not you're allowed to change the schema of the database. Very often, transactional replication just won't work at a database of, say, 10 to 15 terabytes in size, where the transactional replication says you have to make these 5 changes to the schema in order to make it work. Would it be easier in theory? Yes. In practice, it's just often not. Plus, whenever you want to switch out to new versions of SQL Server, for example, replication can be a real pain in the rear to add in many more subscribers at the 10 to 15 terabyte territory. Crazy mode. So those are the 4 ways that we typically see log shipping being implemented. And don't get me wrong, crazy mode is not something that we see very often. I think I've only seen it 4 times in my life so far. Now, back to reality and the ways that you're going to fix log shipping when you run into common issues. One issue is that when log shipping gets a little bit further behind. So for example, let's say that I'm doing log shipping and overnight my developers did some things that I'm not terribly happy with. Say that they did a huge change to the schema and they rebuilt a whole lot of indexes. And because transaction log shipping relies on me pushing all of the log backups from one place to another, sometimes across a very small network line, it's not unusual for log shipping to get way far behind. Differential backups can help you here. Differential backups have nothing to do with the transaction log. People often think that it's a copy of all the log records that have changed since the last full, and that's not what it is at all. It's all of the data pages that have changed since the last full. Maybe you did a whole lot of logged work to the same pages over and over. Your transaction log volume might be very high, even when your differential volume is still fairly low. Let's look at this on a timeline. Let's say here's the timeline for my primary SQL server. Here's the timeline for my log shipped secondary. On the primary last night at 9 p.m., my full backup finished. My log restores are still running pretty close to real time on my secondary. At 10 p.m., I had a code release that changed all kinds of data. It dropped columns, it added new tables, churned a lot of data. At midnight, I had a nightly batch data warehouse type process that ran that also changed a lot of data. At 3 a.m., I had my index rebuild set up to run. They also changed a whole lot of data. And way down here in my logship secondary, things are getting worse and worse, and I'm further and further behind to the point that when I get into work, I am way queued up trying to copy all of these log files over to my secondary, and I don't see a way for me to get back up to speed very quickly. Here's what I can do. The differential backup includes all of the changed data pages since the last full backup. And it's integrated with log sequence numbers, LSNs. So if I take a differential backup now, when I've come into the office, it includes all of the change data pages. So now when I restore that down on my secondary, now I can just start restoring the log files since that differential, and that's it. The differential includes the log sequence number where I can start applying my transaction log backups. So it lets me leapfrog past all kinds of transaction log files. This isn't something that's going to work every time because, after all, you may have a huge differential backup if tons of changes have happened since the last full. For example, not only say our data warehouse processes and our index rebuilds, we're building new tables from scratch and trashing the old tables, building them in different areas of our data file, the differential could end up being the same size, so this may not fix us. This is something that's a trick, not a strategy, and you'll see me use this trick again later when I talk about in another module solving a problem with transaction log backups in general. A few gotchas around log shipping. Absolutely adore it, but just there's a couple things to be aware of. One is you still need log backups and full backups. Because, of course, if some bozo drops a table, you're going to have to go back to the most recent full and all the transaction logs since. You can roll your own log shipping. There's nothing in here, after all, other than transaction log backups, copies, and restores. You just want to make sure that you're going to have your job be as easy as possible. Rolling your own log shipping is rarely the way to be easy. Third-party tools are total lifesavers here. All of these are about $500 per server, and they have amazing GUIs that make your life way easier. Classic example I see out there all the time is folks run a software as a service company where every client gets its own brand new database. Some of these tools include options that will automatically set up log shipping for any new databases that get added. They also have their own custom extended stored procedures that you can fire whenever a new database gets added so that it's protected right away. They also still have better compression than SQL Server's built-in compression jobs. I'm not saying that you should buy these if all you need is compression, but when you start doing things like log shipping, they just make your life way easier. If you use the built-in native stuff for log shipping, don't touch their log shipping job and don't touch the file names. You either go 100% native or you go 100% your own and third party, but don't change anything with the native stuff. You will break it. Log shipping is fantastically useful for jumping versions in SQL Server. I am not a big fan of upgrading in place. Upgrading in place means you have no backup plan. When things go horribly wrong, you kind of want a plan B. Log shipping is great for that plan B. I go stand up a brand new SQL server, build it exactly the way I want, and I log ship from my old database server over to the brand new database server. At the time that we do a cutover, I just do restore with recovery over on the brand new SQL server and have people do acceptance testing. Make sure that everyone is okay with the data that's on there because I can't log ship back down. I can't take a restore from or backup from SQL Server 2016 and restore it back on, say, 2012. T-SQL is a little bit more helpful than the GUI if I'm using native log shipping, because with T-SQL in the MSDB tables for log shipping, I can see the exact file targets. Sometimes when people set up log shipping, they point it at drive letters instead of UNC paths, and drive letters can change, especially with things like map drives, or when something used to be a file share and somebody changed where that file share points to. The last gotcha with log shipping is security, and I don't mean around the backup files, I mean around people querying the database. What if you want to let people query the reporting secondary, but you don't want them to query the primary? In order to get their username into the database, the only way that you can change the database is to do it on the primary. So I have to create their user account on the primary, which I may not want to let them log in and query. The two common ways to do this is first that you grant access through stored procedures and views into a different database. This is a giant pain in the rear. I hate dealing with security chaining, going back and forth between two different databases. So the more common one is option 2. On the primary, I go create a login for this person, which then gets them into the user databases, but I deny login access. Now, the deny access for login or disabling the login happens in the system databases master. That's the part that does not carry over to the secondary. So as long as I create their login on the primary, but just disable their login permissions, I can then let them log in on the secondary and query all their data. Starting with SQL Server 2014, there's an even boss way to do it, creating a server role and granting them these two capabilities: connect to any database and select from any data. These two roles are brand new, and what they give you the ability to is anytime any new databases are added, even if their user account isn't in the database, they're allowed to connect to it and query anything from it. It's almost like SA for reading data, but it is like SA for reading data. You can read anything, including system databases, and you don't get to pick and choose which databases they have access to. It's everything. So this works kind of well on things like data warehouses or reporting servers where people are going to query all of the databases anyway. So in summary, log shipping is still magical. This is still probably the #1 disaster recovery solution that we recommend out there. I'm even seeing it used more often for a higher availability solution just because it's so bulletproof, works across domains, there's no clusters required, machines can be in work groups, they can be in the DMZ. It works beautifully with cloud scenarios where I've got stuff in Google and some in Amazon and some in Azure. I don't have to worry about any communication between those. It's just a matter of restoring data and having it ready to go and query. Works beautifully in Standard Edition. This is also the kind of feature that I don't see Microsoft ever pulling. Even if they tried to pull the feature, it's just a technique. You can do it with any third-party tool or your own scripting. There was a brief moment in SQL Server 2000 where Microsoft decided that log shipping would be an enterprise-only feature, and the third-party vendors absolutely adored that because they could simply sell it as their own third-party stuff. Fred says, can you use log shipping with SAN snapshots and backup tools? So it depends on the vendor. Typically, though, with SAN snapshots, you end up just refreshing the whole snapshot because you can take snapshots and replicate those fairly quickly. It's easier to do that than getting any transaction log stuff involved. And plus, too, with SAN snapshots, they only have the volume of whatever the data change is. With log shipping, you're going to need the whole volume of the underlying database.